Designing a crop rotation is kind of like taking care of your favorite pair of work boots. You're going to be wearing them for a really long time, and you love them, and you have to be able to work efficiently and comfortably in them. Picking the right one is all about, balancing. Are they the right fit? Are they sturdy yet flexible, supportive yet comfortable? Oh, and do they aggravate that toe you broke a few years ago? When it's time to get new work boots, you're not going to just go with the first ones you see. You're going to shop around, try on a few pairs, and get the ones that are the best fit. Heck, those boots are going to be expensive. The investment needs to last for years. Once you have the boots, you're going to adjust them, break them in, waterproof them, oil them up. Maybe you're going to even order some custom insoles. You'll adapt those boots to make them fit to the conditions that you work in. In this lesson, we'll walk you through a set of example crop rotations that help you get a sense of what the possibilities are. These examples are by no means prescriptive. Remember, we're just shopping around here. The crop rotation you select is going to be the one that's just best for your situation, and it's going to be different for other people. It must be responsive to the conditions in real life. All right, let's stop talking now and just dive into it. We've divided our examples into two agronomic regions, the humid east and the semi-arid west. We're going to compare two rotations per region, one short, 2 years or less, and one long, 3 years or more. We'll look at how these rotations would likely perform in some common scenarios. Let's start with that oh-so-beautiful semi-arid west. In this region, we have a lot of options to play with. The area is well suited for growing a host of cereal grains, oilseeds, as well as pulses. But corn and beans are two crops that we're not going to be talking about in the West because they use a lot of water, and guess what we don't have in the West? Hardly any water. All right, let's start with that short western rotation. Year 1, we're going to start out with that classic hard red spring wheat. But with it, we're going to sow in some yellow blossom sweet clover. Now, yellow blossom sweet clover is a biennial, so it's not really going to grow very much that first year. It's the wheat year. The second year, year 2, is when the yellow blossom sweet clover really takes off and gets a ton of biomass, fixes a lot of nitrogen, and ultimately could become a weed if we don't take it out with a disc or hay it off for feed. Now, year 3, we're going to be looking at going back to wheat and ultimately, again, underseeding our yellow clover. So you're going to be going wheat, clover, wheat, clover. Not a very long rotation, but it kind of works. Now, so what are some of the good points of this rotation? We get to eliminate a little bit of tillage between the wheat and the blossom clover by interseeding that yellow blossom sweet clover right with the wheat during that first year. When it comes up, we terminate it, and that's when we have our tillage again, almost more than a full year later. The yellow blossom sweet clover also fixes a ton of nitrogen so that we can keep the soil well fed and ultimately produce high quality crops. This rotation, though, does have some limitations, and let's look at them. So what are some of the downsides to this rotation? Whenever you only have 2 crops in the rotation, you are setting it up to be a really good, ultimately, meal for pests and diseases. You're going to be inviting those pests and diseases to come by your field every other year to snack on that wheat. There's no guessing here. They know when it's going to happen. So a long rotation is going to help us out there. So let's look at what a long rotation would look like. Year 1, start out with that spring wheat and that yellow blossom sweet clover. Year 2, we're going to terminate that sweet clover either by disking it in or haying it off. But then we're going to give the field a rest for the rest of the year. Now, year 3, we're going to come in with something other than wheat. Something, say, like a spring planted flax. It's an oil seed. It's got nothing to do with wheat. It's not like the legumes. It's very different, and it's going to be a real bummer for those pests and diseases that were thinking you're going to go back to wheat. Now, the other good thing about something like flax is it leaves a lot of residue on the field. In my opinion, sometimes too much residue. Year 4, spring planted yellow peas. We get a good cash crop with a strong market demand while fixing a pile of nitrogen for whatever cereal crop we grow next. Year 5, we could go back to spring wheat because it's been a while, or we could do something else like sunflowers or go into a perennial legume like alfalfa. This long rotation addresses a lot of the limitations that we talked about with that short rotation while keeping a lot of the benefits. This rotation keeps the soil covered during the winters, helping to reduce erosion. Adding flax and yellow peas increases the diversity of the crops, allowing for more disruption of pest, disease, and weed cycles. On the financial end, this rotation's pretty much a win. Instead of one cash crop every 2 years, this rotation bumps that up to 3 cash crops every 4 years. Okay, now let's shift our attention east. Let's look at the Midwest, your I states, all the way up to New York. In this area of the country, corn and soybeans feature heavily in organic field crop rotations. Cereal grains are present, but they struggle with fungal issues with all that humidity. Pulses and oilseeds are not really regularly grown in the area. Winter crops, on the other hand, have more of an opportunity to get established due to the longer growing season. So let's start out with another example of a short rotation. Now, a really short rotation would be corn, beans, corn, beans, corn, beans. And you could try this, but it's agronomically just not gonna work. You gotta throw something else in there, like wheat, undersown with a little bit of clover, so that you have something other than a row crop, because in those row crop years, you're gonna build up a consistent weed pressure. You're gonna need something other than just row crop after row crop, because you need to be able to have an opportunity to build some of that nitrogen like you'd get from clover, or really interrupt that weed cycle, which would inevitably be thriving if you're only growing corn and beans back to back. So to be clear, in the Midwest and the East, the shortest rotation you can really do is corn, beans, and something else, like wheat or a small grain to break up that row crop interval. When we think about that 3-year rotation, corn, beans, and another crop like a small grains, we still might have a bit of a challenge because you might not have a market for that small grain. You might have more fungal problems and not be able to produce a good quality grain. We really need to be thinking about what else can be a good fit for the region given our limitations climatically. And also, if we're just looking at the mass balance of fertility, corn is a super heavy feeder. Soybeans don't really produce all that much nitrogen, and so we're going to need to grow a big chunk of nitrogen for that corn crop in something other than soybeans. Alfalfa, clover, some longer-term nitrogen fixer is likely going to be necessary to make this rotation hum. And even in the best situations with a really good perennial leguminous crop, you're probably going to have to add in some sort of manure to bump that nitrogen high enough to meet the corn needs. So let's look at a long rotation to address these limitations. Year 1 and 2, alfalfa or forage mix. Take those hay cuttings or graze the livestock on that field. And then year 3, take the final year of hay cuttings or grazing, terminate that alfalfa with fall tillage. Year 4, plant corn in the spring, sow cereal rye to cover crop in the fall. And year 5, terminate the rye cover crop in the spring. Follow with late spring planted soybeans, and after harvest, plant some winter wheat. In year 6, harvest that winter wheat in the early summer and plant some alfalfa as a forage mix. Let's not miss the opportunity here, though, to talk about no-till soybeans. Now, you won't be able to put that rye crop right after corn, so you might have to have an intervening crop, say your wheat. But after that winter wheat comes off in the summer, you could easily follow that with a rye crop that then goes into soybeans the following spring. This long rotation takes care of a number of the challenges posed by that short rotation. The deep roots of the alfalfa are going to fix a pile of nitrogen. When the alfalfa is terminated, the biomass will provide loads of organic matter to feed the soil biology. During the 3 years of alfalfa, the soil is never tilled. It's always covered, and there are living roots in the soil year-round. Actually, the only winter where the ground's not covered in this rotation is when the alfalfa or the forage mix is terminated. The alfalfa and forage mix years also provide an opportunity to integrate grazing of livestock as part of the rotation, boosting your fertility and your revenue. The weed control benefits of a multi-year perennial crop are also a huge benefit. The addition of winter wheat also increases diversity, which will help break that pest, disease, and weed cycle, as well as provide an additional revenue source. The diversity of crops in this rotation provides a meaningful buffer against weather losses as well as market fluctuations. This long rotation does have a few limitations that are worth noting real quick. 1. Just like the short rotation, establishing a rye crop after corn can be tricky. 2. The revenue from the alfalfa or forage mix is dependent on how close you are to livestock growers who want to buy it. In some parts of this agronomic region, there may be insufficient markets for forage. 3. Including both cereal rye and wheat in the same rotation is a potential risk, depending on the market that your wheat is going into. If the rye fails to terminate and goes to seed, that rye can become a weed itself. This is less of a problem if the wheat is destined for the livestock market, but a food-grade market will reject a load if the contamination of rye in the wheat is above the threshold. Now, if a farmer's not grown small grains before, they might not have a seed drill. Or if you want to grow hay, that is a whole other set of equipment. But likely it's the case that you've got some neighbors or custom operators in your area who can do that part of the rotation on a custom basis. Now, like the Western long rotation, the Eastern rotation has many more benefits than limitations. Across the country, both farmers and researchers consistently report that long, diverse rotations are the way to go in organic field crops. So as you begin to design your organic crop rotation, take inspiration from the comparative analysis we explored in this lesson. Crop rotations are living, adaptable things. As conditions change, the crop rotation can and should be adapted in response. Let the market and your farm ecology guide you. Observe, evaluate, and proactively respond with the upcoming crop sequence. If a weed escapes, look ahead at your sequence and adjust as needed. We've said it a lot before. Crop rotation is the foundation for a successful organic farm. It deserves all the time and attention you can afford it. In the next lesson, we'll hear directly from some organic farmers about how they approach their crop rotation.